Throughout history, technical inventions have always influenced the course of society's development. Primitive tools and the discovery of fire were the earliest technical achievements of Homo sapiens. The first industrial revolution was based primarily on the idea of replacing muscle power by the steam engine, and later by electrically powered machines. Today, the introduction of microelectronics is once again radically changing our lives. The revolution taking place today is based on the wide application of computerized intelligence. In the beginning, a computer was a whole roomful of electronic tubes. Today, a silicon chip the size of a grain of wheat does the same job. 100,000 elements, including the central calculating unit, which processes the data fed in, are accommodated in an area of only 5 millimeters diameter. It is on these microprocessors or chips that the new technology is based. They have enabled all the apparatus produced by man to be equipped with a miniature computer and an equally tiny data bank. And the price is not oversized either. Microelectronics has made possible the development of a new, vital and rapidly expanding industry. With its aid, more and more production processes can be controlled by computer. In the logical chain of development in the field of industrial development, the youngest link is the industrial robot. Its appearance can still arouse fear and suspicion of a machine that performs human or animal-like movements in a seemingly supernatural manner. But the multi-axis and flexibly programmable robot is really no more than a manual aid. It can be fitted with gripping devices for processing workpieces, with paint guns, or with tools such as welding torches or spot welding tongs. The employment of robots like these in the automobile industry means that more and more production processes can be automated. The highest degree of automation in the automobile industry has been achieved in car body shell production. Here, 90% of all welding work is already being carried out by robot. Today, BMW employs a total of about 300 robots. A decisive advantage of robotization is the provision it makes for flexibility of production, important for changes of model. Such changes formerly rendered the whole setup unusable. Now the robot only has to be freshly programmed for the new series. These machines are robots of the second generation, even more accurate and reliable than those of the first. So, in the long run, lower production costs are paired with even higher product quality. In theory, robots could take over practically all production processes. A fully automatic factory is possible, but not without people to supervise, to check, and to maintain the equipment. Investment in automation in the automobile industry is already in the multiple millions. These costs will not only have to be recouped, they must also lead to better working conditions. By gradually eliminating exhausting and unhealthy manual labor of all kinds, robots will contribute to the humanization of work in factories. For some areas of production, this will entail a reduction in the requirement for unskilled workers and a greater need for operatives with a job-specific training. Muscle and strain jobs are being replaced by control, supervision, adjustment, and maintenance functions. It is therefore the company's major task to raise the level of qualifications of all workers, even of the more highly trained and specialist workers, to the requisite standard. This will guarantee proper operation and maintenance of the new technology. An example: the welder's job is taken over by the robot. His place of work disappears. He has to be retrained. The major requirement is above all for workers with a certain intellectual standard and who, whether foreigners or not, can speak adequate German. Retraining is conceivable for areas of production where a considerable manual element will still be required in future. For example, parts assembly, engine construction, or gearbox assembly. But the increasing need for more highly qualified workers can only be met in part by retraining in these jobs. Retraining cannot be carried out in every case, since success depends to a large extent on the willingness to be retrained. Those who do not show this willingness are risking their jobs. In cooperation with other companies and professional associations, BMW has developed a new range of specialist jobs. The training programs involved are as yet outside the scope of the federal job training regulations, which do not yet cover what these programs aim at: future work with robots. The multi-job specialist worker scheme, evolved by BMW, aims first at extending the employee's range of mechanical engineering knowledge and skill. Part 2 of the training course is designed to equip him with a thorough grounding in electronic and electrotechnical theory and practice. This will enable him to maintain and repair increasingly complex control and programming installations. The courses leading to the label of manufacturing mechanic or production mechanic are intended to create a type of specialist worker whose main function will be to work on fully automated production. His job will include checking operations, carrying out minor repairs, and ensuring planned maintenance. He will be responsible for trouble-free production and maintaining quality standards. For this, the most broadly based basic training is essential. What is required is the ability to adapt to technological and economic change, the flexibility to use the knowledge acquired in various industrial branches and departments. What we see in factories today is a generation of robots that are still carrying out relatively simple work. To extend the robot's range of application, researchers are beginning to equip the robot with tactile and optical sensors. These systems give the robot a certain degree of intelligence, and with this, the ability to handle increasingly complicated programs. BMW is pursuing its own research in this field. Here, an assembly robot, putting an oil pump together. he has two arms working independently of each other. The parts supply and the grip and assembly movements are under continuous surveillance by the robot control. Following initial assembly, the right arm takes the pre-assembled pump and places it in the screwing holder. The left arm of the robot screws on the housing cover and then places the fully assembled pump on the conveyor belt. This equipment is still under test and is being prepared for series operation. Here the task is picking up cylinder heads and cylinder blocks and passing them to processing points and conveyor belts. For this, a 6-axis robot was equipped with a suction grip. The exact position of the individual cylinder heads is ascertained through an optical measuring and sensor system and conveyed to the robot. The sensor system and the robot are intersynchronized, so that the robot can recall the new position coordinates as required. The time can already be foreseen when robots of this degree of intelligence will be fully employed. They will also be able to deal with those areas of assembly work which have so far resisted automation. Nobody can as yet forecast with certainty exactly what the effects will be of the introduction of so-called feeling, seeing and thinking robots into the factories. What is certain is that this new robot generation will take over the work now being carried out at the conveyor belt to an increasing degree, not only in the automobile industry, but also in other industries. The fears expressed that more unskilled workers will in future be unemployed are justified. But should technical progress be slowed down to give the economy and the labor market a chance to adapt? The answer is simple. Microelectronics means considerable production advantages. Firms who adapt too late endanger their very existence. They can no longer compete. Such a company would put all its employees' jobs at risk. But microelectronics also creates new jobs. These jobs arise through new industries producing new products, new automatic systems. As with all new technologies, microprocessors in the end contribute to an improvement in our living standards and to the better use of resources. So we must either exploit this new opportunity to the full and adapt to coming changes, or we shall see our industrial society collapse, with all such a collapse would entail. Patterns of work will change, and so man's life will change. For one thing, hard physical labor won't be required. But man will still have to be creative and achievement-minded. For productivity must increase in the face of increasing competition. So we shall not have less work to do, but we shall need less time to do it.